Hello again, it's another A-Level Maths video here. We're looking at the Pure Maths Year 2 stuff at the moment. Section 2.2 of the textbook, which is headed Functions and Mappings. So we've seen functions before, right? We know that a function is a relationship that maps an input value to an output value. It's a kind of a wider set of things called mappings, which we'll talk about that word mapping a bit later in the video in a bit more detail. But we've got a couple of definitions on the screen which I just want to make sure that we are familiar with. The set of allowed input values for a function, that's known as the domain of the function. And the set of all possible output values for a function, that's known as the range of the function. You familiar with those words? You may have seen them before, you may not have done. But either way, we're going to have a look at those things now. So there's an example here on the screen, which we're looking at the function f of x, which equals x squared. So a nice simple function. But we're not allowing ourselves to input all real numbers into this function. What we're going to do is we're going to restrict our input numbers to only numbers x which are greater than or equal to 2. So to use the language, we would say that the domain of the function is the set of all numbers x greater than or equal to 2. And let's see if we can use that information to find the range of the function. That would be the set of all possible output values. Now, I think the most useful way of looking at this is to actually consider what the graph of the function looks like here. So I've got the graph plotter to help me here. I've got it to plot the graph of y equals x squared, which is the function we're interested in. But of course, we're only interested in the input values, the x values greater than or equal to 2. So here's our domain here, x values greater than or equal to 2. So that means that we've only got this part of the graph here. And what we're interested in, of course, is the range of the function, which are the possible output values. So those would be the y values, the corresponding y values, which relates to these x values over here. So I think what we need to do is we need to first of all work out, the end point there, and then we need to say to ourselves that the range of the function there is all of these y values here, which we can see. So in this particular case, that would be the set of values greater than or equal to 4. And here's how we might write that down. So we might say that the range of the function here, called f, would be the set of y values or output values. Now we'd have to write f of x there, and we're looking for all values greater than or equal to 4. So any number greater than or equal to 4 could come out of this function here. So that's our range of that function. Okay, so I hope that makes sense to you. So let's see if you can have a go at some questions here. So I've got some other functions here. They're still all have the same rule, just the x squared function, but with different domains, so different sets of input numbers. Can you pause the video and see if you can work out the range of these two functions I've put on the screen here? Okay, so how did you get on with this one? So this is the function g, and you'll notice the domain here has been restricted to just the numbers less than -1 here. So looking at the graph, the bit of the graph, the y values here, the range would be all values greater than 1. So let's write that down. So the range of g, we'd have the g of x, the output numbers, is the set of all values greater than 1. Okay, what about function h? Well, let's have a look at the graph of function h. There it is here. So you've got the domain here is just these values here between -2 here and +3. And the range are all the possible y values. Now, hopefully you didn't forget about this bit here because the graph dips down before it goes back up again here. So all the possible y values are all the values between 0 here, this minimum point, and this point up here, 9. So let's write down that as an answer here. So the range of h, this will be the values h of x, which are greater than or equal to 0, because we could get 0 coming out of this function, but which are strictly less than 9 because there's no input value, which would lead to a value of 9 here. Okay, did you get all of that correct? So there we go with our definitions of range and domain. Hopefully that made sense, and I would strongly encourage you, whenever you're considering range and domain, to consider the graphs of the functions to make sure that you're including all those bits that you need to. Right, a couple more definitions that we need to know about here, though. We need to know about functions, whether they are one-to-one functions or many-to-one functions. I've put some definitions on the screen there. A function is one-to-one if each value of x in its domain, so that, remember that's the input numbers, maps to a different value of f of x. Okay? And then a function is many to one if at least some values of f of x can be obtained from more than one value of x. And I think I probably want to show you an example or two to show you what this is all about, really. So let's have a look at two functions here. One of them is a one-to-one function and one of them is a many-to-one function. And I'll try and explain why they are as they are. So here's the first function. I've called it f. It's the function f of x equals 2x plus 1, and no restriction on the domain of the function. I'm going to allow any real number to be the input of the function. And I've worked out a few of the values I get, a few of the output values. And I'm noticing that each of these output numbers are different from each other. Okay, so we don't have any output numbers which are repeated here. So these are all different numbers. Okay, but I've got another function over here which I've also called f. This is a quadratic function. Here's the rule here, x squared minus 2x plus 3. Again, no restriction on the domain here. I'm just going to allow any real number to be input into the function. And I've worked out some output numbers here, but I've noticed this time I've got some repeats. Yeah, can you see here that the 6 is the output of when I input -1, but it also is the output when I input 3 here. So f of 3 equals f of -1. I've got the same output number appearing for two different input numbers. I can see another example here. The 3 is coming when I've got an output, when I've got an input of 0 and when I've got an input of 2, we end up with the same thing there like that. So these are not all different. Okay, so what that means is that these ones which are all different, this is the example of the one-to-one function. And then the ones where they were not all different, this is the example of the many-to-one function. Now, if you're still struggling to kind of get your head around what's going on there, let me show you the graph. So you can see here, if I pick an output number, I happen to have picked the number 6 here. For this second function, the many-to-one function, I could get the output number 6 from more than one input number. In this particular case, two input numbers. And you can see I could even choose different output numbers, and you'll see, hopefully, if the graph plotter, there we go. Then you can see if I pick a different output number, there's quite a lot where we can get there from more than one input number there like that. Whereas if I look at the example of the one-to-one function here, which was had a straight line graph here, every output number here we can get to from just one input number here. Doesn't matter where I pick my output numbers. I could move this around here, pick different output numbers, and you can see there's only ever one input number which would lead to any particular output number. So again, considering what the graphs look like is really helpful in determining whether a function is one-to-one or many-to-one. Okay, your turn now. Can you pause the video, answer the question on the screen, but I'm just going to give you a word of warning for the last function there. Notice that the domain has been restricted, so we're not having all real numbers in that function h at the bottom there. Okay, so let's check some answers here. I've sketched some graphs here. So the first one here, the function f of x, domain is all real numbers, so it's the entire straight line here. And again, you should be able to see that that must be a one-to-one function, because any output number can be reached by at most one input number. Okay, function g, let's move on to that one. So here's my graph of function g, and you'll see here that we've got, again, the domain is all real numbers. This particular graph is showing us that we have a many-to-one function, because if I can pick an output number like this here, and we can get to that output number from more than one input number potentially. So that's a many-to-one function. And what about function h here? Well, I've been very careful with this one. I've sketched the graph again. This one, we had the restricted domain. We could only have values of x greater than or equal to 0. So this is the only bit of the graph I've got. And notice now that makes it a one-to-one function. Each output number, wherever it happens to be, you can only get to it from at most one input number. Okay, so there we are with our one-to-one and many-to-one functions. Hopefully that made sense. If you need to go back, rewatch, pause, think about it, of course you should do. We've got still quite a bit more to go in this little section of the book here. So What I want to talk about now is I want to talk about relationships which are not functions, because we do have mappings, we do have ways of mapping input numbers to output numbers which don't necessarily define functions. We still call them mappings, but they're not functions. And the reason why it might break down is that for every, in a function, every input value has to map to exactly one output value. And if that doesn't work, then we do not call it a function. So there's two basic ways which that can break down. The first way it can break down is you can have an input value that maps to more than one output value. And the second way it could break down is you could have an input value which doesn't map to any output value at all. So let's get you thinking about that idea straight away here. I've put a question on the screen here. There's actually two different relationships here, two different mappings, we could call them. But these are not functions. Can you work out, based on what we've just said, why these relationships would not be called functions? Okay, so let's have a look and see what we could have been thinking of here. The first one here, I could pick any value of x I like, really, as long as it wasn't 0, but I could pick any non-zero value of x I like, and I can see I'm going to get two values of y coming out. Let's show you an example. If x equals, let's say x equals 3, then y would be 3, or y would equal -3. We've got a single input leading to more than one output, not a function. We don't call those things functions. The second one, I think this one's slightly trickier to see why this one isn't a function, but there is one number in our domain, in our set of input numbers, that is going to cause this to break down. If I try and pick x equals 0 here, then I'm trying to get a y value which is 1 divided by 0, and of course that's undefined. So that means that there's no y value for that particular input value of 0. That means, again, not a function. Now, of course, we still do deal with these kind of things in mathematics, don't we? We can call them mappings, but if we're going to use that word function, we have to have that restriction that we have one input leads to exactly one output all of the time. Okay, let's move on. One last thing we need to talk about in this video, and that's this idea of something called a piecewise defined function. Now, I'm hoping this is not a difficult idea for us. But basically, the idea of a piecewise defined function is that it just has different definitions for different particular input values or different parts of its domain. For example, the function I've put on the screen here. You'll notice that this function f of x has two different possible rules that we could use for the output. We could get the value x squared if the values of x, the input value, is less than or equal to 1, or we would get 2x if the input value was greater than 1. And I'm hoping that's straightforward enough that you can actually just pause the video right now and write down the values of the three things I've put on the screen there for you. Okay, let's go through these here. So here's my function here. The piecewise defined function has these two different rules. Here's what you should have done. F of 3, so if the input is 3, we need to work out which of the rules we're interested in here. Well, 3 is obviously greater than 1, so we're looking at this rule here. So we must take 2 times the input number, 2 times 3, and we get the answer 6 there, like that. Okay. What about the input number of -2? Well, if the input number was -2, we're looking at which of the rules here. Well, -2 is less than or equal to 1, so we're looking at this rule here. We've got to take our input number, and we've got to square it. So if we do that, we get the answer 4 here, like that. Okay, and what about the last one that we had here, f of 1? Let's write this here. So again, we just need to kind of look which of the rules are applying here. Okay, we need to be careful here, but we can see that here this one includes 1, this one doesn't. So we're looking at the first rule here, x squared. We need to take our input number and square it. 1 squared is, of course, 1. So therefore, for this piecewise defined function, f of 1 is equal to 1. So why don't we have a look at the graph of this function here, this piecewise defined function, because there are one or two conventions which we just need to make sure that we know about here. So I've got my graph plotter to actually plot this graph for us. You can see here that, again, you can see the two different sections of the graph here. And notice here that the solid dot here, the solid dot is telling us we're including that endpoint. the sort of open dot here, this dot which hasn't been filled in with the color, that's our convention to tell us we're not including the endpoints here. So if ever you're asked to sketch a graph which is piecewise defined, you might need to just pay attention to that, bear that in mind. Okay, so this is going to be the last question of the video here. I'm going to ask you to see if you can piece together all of the ideas, or most of the ideas we've come up with so far in this video. I've got a piecewise defined function there. I'm going to ask you to sketch the graph of it, state the range of this function once you've got that graph, and then state whether this function g is a one-to-one function or a many-to-one function. Let's see how you get on. Right then, let's see if we can look at some answers, and hopefully you agreed with this. I've already sketched the graph here. So this is the graph of the function y equals g of x. You'll notice that this branch of the graph here is basically the part of the straight line y equals 3 minus 2x. And then this part of the graph here is part of the other straight line y equals x plus 2. And I've filled in the solid dot here at the end of this, this line here, but I've left an open dot here to represent the fact that we're including this endpoint, but we're not including this endpoint here. So that hopefully you agreed with that. Now, range of this function, well, that's the set of all possible output values. So on the graph, that's really the y values, isn't it? So the range of this function, I'll write there here, the range of the function g, it's going to be the set of all values less than or equal to 3. So g of x is going to be less than or equal to 3 here. We can see we can get any number which is less than or equal to 3 out of this function. We can even get 3 because it's included here, but we can't get any values above 3 here. So therefore, that's our range of our function. Finally, is this a one-to-one or a many-to-one function? Well, again, considering the graph, we should work out that this is a many-to-one function. There are some values in the output in the range here. Let's pick one down here, which we can get to from more than one input number here. Okay, so we can see there's an input number over here and an input number over here, which would lead to the same output number there. That means it must be a many-to-one function. So quite a lot of stuff in this section of the book, right? Lots of definitions, lots of ideas. Please do go back, re-watch bits of this video if you think you need to. Once you've got the idea, then exercise 2B in the textbook is where to go for your practice questions. But that's it for this video, and I'll see you again next time.